All right, class, today we're going to start chapter 4, which is all about polynomial and rational functions. A lot of what we're learning in chapter 4 is going to be some review chapter and materials from last year when you took Algebra 2. So this will be kind of a review section. However, it's really important that we know about our rational functions going forward in other math classes. We're going to kind of review these. It will also help for you juniors who are taking the SAT in the spring to kind of review these chapters that you might have forgotten from last year. Okay, so the first thing that we're going to talk about is polynomial functions. So the first couple of sections that we're going to be talking about is polynomials. So what is a polynomial? A polynomial in one variable, typically x, has the following form, right? So we've got a number x to the n plus a number x to the next lowest exponent, right? So if this was x to the third, then this would be x to the second, plus a number x to the first, all the way down to where we just have our constant with no x, so like plus 5. Okay, so that's the form of a polynomial. Where n is the degree of the polynomial, it must be an integer, and a is the coefficient. Okay, polynomials cannot have negative exponents or variables in the denominator or fractional exponents. Okay, so our exponents have to be integers. They cannot be negative, they cannot be in the denominator, and they cannot be fractions. So if we have 3xy to the negative 2, that is not a polynomial. If we have x on the bottom of this fraction here, that is not a polynomial. If we have x to the 2/3, that is not a polynomial. Okay, it must be an integer, and it must be rational. If we had something like x to the pi is 3.14, repeating, right? So that would not be a polynomial. Okay, so in the next 3 examples, it wants us to determine if each is a polynomial. If yes, then state to the degree and the leading coefficient. Okay, so we have 8 minus 3 over x squared. Well, we have x on the bottom, so that would be no, it is not a polynomial. In this problem, we have 2x to the second, that's okay. 4x to the 1, that's okay. So yes, this is a polynomial. Now the degree of the function is always the highest exponent, so our highest exponent is 2. The leading coefficient is the number that's with that highest exponent, which in this case would also be 2. On MathXI, I believe it also asks for the constant term. The constant term is the one without any x's, and that would be 1 in this case. Okay, number 3, we have x to the 2/3. That would not be a polynomial because we have a fractions 2/3. Okay, so now that we've talked about what is a polynomial, now let's talk about polynomials and their zeros and multiplicities. So a zero is just another fancy word for x-intercept. So a 0, x-intercept, a root, all 3 of these mean the same thing. Solution, they all mean x-intercept. Okay, now multiplicity is how many times it occurs. So in this first example, we have x minus 1, x plus 2, and x minus 4. So that means we have 3 real zeros. The zeros are, if I were to set this equal to 0, sorry, x minus 1, I would have to add the 1 to the other side, so I would get x equals 1. If I were to set this one equal to 0, I would get negative 2. If I were to set this equal to 0, I would get 4. So the zeros are 1, negative 2, and 4. Now all of these have multiplicities of 1. So the way we would write that is 1 multiplicity 1, negative 2 multiplicity 1, and 4 multiplicity 1. Now why does it have multiplicity 1? Well, it's only occurring one time. There's no exponent here telling us that it's happening more than once. Compared to example 2, we have x plus 1. If I set that equal to 0, I'd get negative 1. It's only occurring once, so multiplicity 1. If I were to set this equal to 0, I would get negative 3. And it has an exponent of 2, meaning it's happening twice, right? If it's squared, it means that I could write it 2 times. So it has a multiplicity of 2. So in the next examples, it wants us to find the zeros and to find the multiplicities. So in the first example, if I set this equal to 0, I would get 1 multiplicity 2, negative 6 multiplicity 1, negative 10 multiplicity 1, positive 3 multiplicity 4. Now in this example, I've got 4 multiplicity 3 and negative 2 multiplicity 2. However, I also have a third 0, and I kind of skipped it. I want you to look at the difference between these two problems. In this problem, I have a leading coefficient of negative 2. In this problem, I have a leading coefficient of 3, but if you look, I also have an x right here. So because there is also an x there, that means we have a 0 of 0 with multiplicity of 1, because the exponent here is just a 1. So you have to make sure you're paying attention to the difference here. If this is just a negative 2, there's no x with it, then it doesn't mean we have a multiplicity, right? We don't have a 0 of 0. In this problem, if I have an x, then that means I do have a 0 of 0 with a multiplicity of 1. Okay, so now let's talk about end behavior. Okay, so end behavior, we've got 4 different things that could happen with our polynomials. So we could have n is even, n is odd, and then we could have the coefficients is either positive or negative. Okay, so when I'm talking about this, we're talking about a x to the n. So if n is even, okay, when n is even, and a is positive. So for example, positive 2x to the 6th. Okay, this is even, this number is positive. That means our arrows are going to be going in the same direction, and because it's positive, they're both going to be pointing up. Okay, now I'm not talking about what's happening in the middle. I don't care what's happening in the middle. I'm just worried about what's happening at the ends. So at the end, our left arrow is going to be pointing up, and our right arrow is also going to be pointing up. Now when n is even, but a is less than 0, so if I have a negative 2x to the 6th, instead of both arrows pointing up, both arrows are going to be pointing down. Okay, so when n is even, the arrows are together. They're either both up or they're both down. Now, when n is odd, so if our exponent is odd and our a value is positive, so positive 2x to the 5th, what happens is our arrows are not going to be together anymore. One's going to go up and one's going to go down. So if it is positive, from left to right, I want it to be pointing up. So it's going to start down, and by the time we get to the right, it's going to be pointing up. So from left to right, it's increasing, it's positive, it's increasing. Compared to if a is negative and x is even, the power is, odd, it's going to be going down. So it's going to start up, and by the end, it's going to be going down. So in number 1, it wants us to find the end behavior of the following functions. So we've got 2x to the 5th. So because this is odd and this is positive, our arrows are going to be going in opposite directions. And because it's positive, the right arrow is going to be up. So end behavior, as we wrote last year, as x goes to positive infinity, y goes to positive infinity. It's pointing up. As x goes to negative infinity, y is going down. Okay, number 2, we've got negative 5x to the 4th. So 4 is even. And then we've got a negative. So even means our arrows are together, negative means both down. So our arrows are going to be like this. So as x is going to negative infinity, y is going to negative infinity for both directions. Okay, example 3, we're going to use our highest term. Our highest term here is negative x to the third. So I want you to pause the video here and write your answer for number 3, and then unpause and check. So we've got an odd and negative. So it starts up, ends down. So on the negative side, it's going up. On the positive side, it's going down. Okay, so now we're talking about y-intercepts. So a y-intercept is where it hits the y-axis. So if we think about that, that ordered pair would be 0, a number. So if I want to find a y-intercept, we're going to make x 0. So to find our y-intercept, I'm going to make x 0. So that gives me negative 1 squared times 6, which gives me positive 1 times 6, or 6. So our y-intercept is 0, 6. Just like we did in the last problem, I want you to pause and try these two, and then unpause and check your answers. Okay, so for number 2, I plugged in 0 for x. I have negative 2 times, oh, this should have been positive 10. So this would be negative 20, so negative 1620. And then on number 3, if I plug in 0 for x, I'm going to have 3 times 0 times the number times the number. Well, anything times 0 is 0. So our final answer here is 0, 0. So why are we doing all of these things? Well, the purpose of knowing how to find the zeros, the y-intercept, and the end behavior is for graphing polynomials. So in these next couple of problems, we're going to take everything that we just did and put it together so that we can graph our polynomials. So when we are graphing our polynomials, we're going to identify the end behavior power function. Notice this doesn't just say end behavior. It says end behavior power function. So that's different than what you did in Algebra 2. I'm not asking for end behavior. I'm asking for the power function. Okay, the power function is what would the leading coefficient be in leading degree if I were to multiply this all out. Well, if I was going to multiply this all out, this 2 would still be there, right? So for our power function, our leading coefficient is 2. And if I were to multiply this all out, I have x times x squared, which is going to give me x to the third. So our power function is 2x to the third. I'm not asking as x goes to infinity, y goes to whatever. I don't care. We're moving on past that. That was Algebra 2. Okay, number 2 says plot all the zeros. So if I look here, if I set 2 equal to 0, that's not going to give me a 0. If I set x plus 1 equal to 0, I'm going to get negative 1 with a multiplicity of 1. If I set x minus 2 equal to 0, I'm going to get positive 2 with a multiplicity of 2. So I've got zeros at negative 1 and positive 2. Okay, then we're going to plot our y-intercept. So we're going to set x equal to 0. So we've got 2 times 0 plus 1 times 0 minus 2 squared. So it gives me 2 times 1 times 4, or 8. So our y-intercept is 0, 8. So I'm going to plot the y-intercept. Okay, we're going to draw an approximation of the curve. Remember, the highest exponent tells us how many turning points there are. So let's look at our power function. Our power function is 2x to the third. So because this is positive and this is odd, it's going to start down and it's going to end up. And because this is x to the third, we're going to have 2 turning points. So it's going to end up, it's going to start down. And we're going to have 2 turning points, so 1, 2. So it might look something like this. Okay, now we have to figure out what's going to happen at each of these zeros. So when a 0 has an odd multiplicity, the graph will cross or go through. When a 0 has an even multiplicity, the graph will bounce. Sometimes you'll see the word touch It'll just touch the the x-axis, or it'll bounce, or it'll cross. Okay, so at our multiplicity of -1, we have an odd multiplicity, which means it's going to cross. So I'm going to start down here at my arrow. I'm going to make it way up here, and it's going to cross through. I'm going to make my way up to my y-intercept. Come back down. I'm going to make my way to my next 0. Now at this 0, I have an even multiplicity, which means it's going to bounce. Make my way back up to my arrow, and here is my approximation of my graph. Okay, so this means cross, this means bounce. Okay, let's look at the next example, example 1. Okay, A wants us to find the zeros and the multiplicities. We have an x squared here, so that's going to give us a 0 of 0 with a multiplicity of 2. And then x plus 3 is going to give us a 0 of -3 with a multiplicity of 1. Part B, we want to find the x or the y-intercept, so I'm going to plug 0 in for x, which 0 times anything is going to give us 0. So we've got 0, 0 for the y-intercept. Part C wants us to find the power function, so we've got y equals -1 x. I've got x squared times x is going to give me x to the 3rd. And now we want to sketch the graph. So my zeros are 0 and -3. My y-intercept is 0, -x to the 3rd. So it's going to start up, it's going to end down, and we're going to have 2 turning points. 1, 2. So it's going to start up. I'm going to head down. At -3, this is a odd multiplicity, so that means it's going to cross. I'm going to make my way back here. This is an even multiplicity, so it's going to bounce. And we're going to end down. Now they match. Okay, so I would like you to try example 2 and example 3. So pause, try example 2 and example 3, and then unpause and check your answers. Okay, with example 2 here, so I started with my zeros. I started with at -4, it crossed. At 0, it crossed. Now at 3, it bounces, right? So I should want to go up here and end this. However, remember that if this is x to the 6th, it should have 5 turning points. And if I look right now, I only have 1, 2, 3 turning points. So I'm going to have to add an extra 1 in. Now I have 1, 2, 3, 4, 5 turning points, and I'm done. It doesn't really matter where you put this extra turning points. You could have put them over here if you want. I tend to just start on the left, work my way through, and then say, okay, do I have enough? No, let me add it in. Okay, don't mind my messed up graph here, but started with my zeros of 1 and -4. It's going to bounce at 1 and cross at 4. I've got a y-intercept of -32, so I just kind of added that at the bottom here. I made sure I labeled it. Our power function is -2x to the 3rd, so it starts up, it crosses, go down to -32, up to 1, bounce, down. So kind of ignore this little piece. I messed up. I started to go to the 1 before I went down to my y-intercept.